Let me talk about the concept of fixed points and stability, here linear stability, applied to a one-dimensional differential equation. So we have our x, which is a function of time. So let's look at a differential equation x dot equals some function of x. So we assume that there is no time dependence on the right-hand side. So a fixed point of this equation is one where you, if you start x at the value of the fixed point, say x star, then x will always stay at x star, which means that the derivative at x star will be 0. So a fixed point x is x star will satisfy then that the derivative with respect to time that the derivative with respect to time is 0, so that f of x star equals 0. So if you start at x equals x star, you'll always be at x equals x star because the derivative is 0. So then the question becomes the stability of the fixed point. So to determine the stability, you want to move x a little bit away from x star. So we let x then be nearby x star, so x of t equals x star, and allow it to move slightly away from x star, so plus epsilon of t. So we perturb x star. So at t equals 0, we have some perturbation, so epsilon of 0 then is supposed to be some small perturbation, which I'll call epsilon naught. So now the question becomes what happens to epsilon as we solve the differential equation. So we can substitute x into the differential equation. The derivative of the constant is 0, and then the derivative of epsilon becomes epsilon dot. So we have epsilon dot equals f of x, which is f of x star plus epsilon. We assume epsilon is small, a small perturbation to the fixed point. So we can make a Taylor series expansion here about x equals x star, or about epsilon equals 0. So we have the constant term f of x star plus the linear term epsilon times f prime of x star plus epsilon squared over 2 factorial, but these terms are going to be higher. So what we're going to do now is a linear analysis. So in a linear analysis, we're going to throw away all those dot dot terms. So we're going to say that all of these terms are negligible. And then we'll only have the linear term. So that's why it's called a linear analysis. So x star is a fixed point, so that this term is 0, f of x star equals 0. So then we have the differential equation for the perturbation, epsilon dot is equal to epsilon times f prime of x star, which is a constant. Okay? We can solve this differential equation. We have the initial condition epsilon of 0 equals some given small value, epsilon naught. This is a separable equation, but we should know the answer. The time derivative of epsilon gives us back epsilon times a constant. That is an exponential function. So we should be able to write down epsilon of t equals e to the f prime of x star, the constant, times t. And epsilon of 0 is epsilon naught, so this has a epsilon naught in front. Okay? So epsilon is the perturbation to x star, And the perturbation will grow if f prime of x star is positive, at which point we say that the fixed point is unstable. The perturbation will decay if f prime of x star is negative, at which point we say the fixed point is stable. So we say x star is either stable or unstable, stable or unstable, if the derivative of the right-hand side with respect to x of x star is, in this case, stable, it will be less than 0. And in unstable case, it will be greater than 0. Okay? So that determines the stability of x star. What does the graph look like? So if we draw a graph here, this is t, and this is x, and this value here, let's say, is x star. So if we perturb x star slightly larger than x star, if it's stable, then it will decay exponentially to x star. Similarly, if we start below and it's stable, it will decay exponentially to x star. So this is what happens when f prime of x star is less than 0, so that we have stable. Okay? If it's unstable, we can draw a corresponding graph for unstable. Here we have x versus t. Here is our x star. This is the fixed point. If we start at x star, we're always at x star. And then if we do unstable, we start a little bit away, and the solution will run away exponentially. We start a little bit below, the solution will run away exponentially. So here f prime of x star is positive, and this is unstable.